So I'm not going to explain exactly what factorials are used for yet, but I want us to just get comfortable with it first, and you'll see why we need it a lot for the first part of data management. Okay, so this symbol here, n stands for any positive integer number. If you write n exclamation mark, this means n times by n minus 1 exclamation mark, given that 0 factorial is equal to 1. Okay, so what does this mean? So if I have a 3 factorial, according to this definition, it's 3 times by 2 factorial, right? 3 times by 1 less factorial. But then that right there can be repeated, this definition, and becomes 3 times 2 times 1 factorial, right? So I just focus your attention on that part and use this equation again. So that number itself, and then decrease by 1, and factorial again, and then it becomes 3 times 2 times 1 times 0 factorial, which is stopping at 1. So 3 factorial effectively means then 3 times 2 times 1. The pattern will continue. 4 factorial means, right, 4 times 3 times 2 times 1. So these are large numbers. Like, they can get large really quick. If I put like 10 factorial, it's gonna be a huge number. Okay, so here's the example. So recall that a number, you know that it's gonna end with a 0 if it has a factor of 10 in it. So let's say I had 3 times 2 times 5. I know this is gonna end with a 0 because 2 times 5 is a 10. Right? So it's gonna end with 1 0. Do you see? 10 factorial is 10 times 9 times 8 times 7 all the way down, right? Let me just write it all. If I increase this to like 30 factorial, it's not really realistic for me to write everything down. You need to find the pattern. But for this one, let's just write everything down. You need to look for number of how many factors of 10 there are in this list of multiplication here. Right? How many will there be? Obviously, you see one right off the bat, right? Now, to make a 10, you need a 5 and a 2. Which factor do you think you have more here, a 5 or a 2 in here? We have a lot more 2's. So which one do you think you need to count? The 2's? So we need both 5 and a 2 to make a 10. So do you think you need to count the number of 5's, the number of 2's to make sure we have the exact correct number of 10's? So there's only one more 5 in here. You can see it, right? So this number, I just asked you how many zeros does it end with? It's going to be something, 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 ending with 2 zeros. Right? So what this means is that as factorials get bigger, it's going to end with more and more zeros. Okay? Because as you put higher factorial, you're going to have more number of 5's, right?